Stay home, save lives.
After discussing the basic nature of amines, let's look other chemical reactions shown by amines. That is, first we are discussing acylation. Acylation, its usual meaning is replacement of hydrogen atom by acyl group. What is acyl group? Acyl group is RCO group. R can be any alkyl group here. This is acyl group. So in acylation, when acylation of amines is taking place, hydrogen atom which is attached to nitrogen, that is replaced by acyl group. That is why acylation is shown by primary and secondary amines, because we know tertiary amines, the general formula for tertiary amines is R3N, and here nitrogen do not have any hydrogen attached with it. Therefore, acylation of tertiary amines cannot take place. Let's look at the equations showing the acylation. Look at this equation. Here we have taken C2H5NH2, a primary amine. It is ethanamine, and the reaction is taking place with CH3COCl, that is acetic ethanoyl chloride. And this reaction is taking place in the presence of a pyridine, which is a strong base, even stronger than any amines itself. Now acylation will take place. Hydrogen, one of the hydrogen atom of this primary amine will be replaced by this COR, that is acyl group, and one hydrogen and chlorine combinedly will be removed in the form of HCl, and see the product C2H5NH, one hydrogen has been replaced by COCH3. So what is this compound? You can see in this compound CONH2 can be considered as the functional group in it, which is amine. But with nitrogen, one hydrogen is replaced by C2H5, that is ethyl here. So how will we name this compound? N-ethyl. The source of the alkyl group with which it is bonded also has to be mentioned, that is nitrogen. So N-ethyl, and these two carbon atoms will be the part of the parent compound, that is eth, and the functional group is amine. So the complete name will be N-ethyl ethanamide. In general, we can say acylation of primary or secondary amines results in the formation of substituted amines. Let's see one more equation showing the acylation, that is of aromatic amine we have taken here. This is a primary aromatic amine. Common name of this amine is aniline, and the reaction is taking place with acetic anhydride. Here we have taken anhydride. IUPAC name of this compound will be ethanoic anhydride. Again acylation will take place. One hydrogen atom of this amine, aromatic amine, will be replaced by COCH3, that is acetyl group, and look at the product, this benzene ring NHCOCH3, and side product will be CH3COO and one H from here, that is acetic acid. How will we name this compound? Again, this compound is having amide as the functional group, that is CONH2, but with this N, phenyl group is binded. So name of this compound will be N-phenyl. Parent compound will be of two carbon atom, that is ethanamide. So these two equations are showing how acylation of primary or secondary amines takes place. Secondary amines will also take place in the same way. One hydrogen atom of them will be replaced by acyl. Now next equation, it is similar to acylation, that is benzoylation. Just like acylation, benzoylation is the replacement of hydrogen atom by benzoyl group. What is benzoyl group? See, RCO is acyl group. If in this acyl group, in place of this R, it is C6H5 group. That is C6H5 group. It is benzoyl group. C6H5CO is benzoyl group. So benzoylation is replacement of hydrogen atom by benzoyl group. And for For this, the reaction has to be reaction will take place with benzoyl chloride. Let's look at the equation. You can see here we have taken here CH3NH2. Again, here it can be a primary amine, it can be a secondary amine. This is methenamine. Treatment is with C6H5COCl, that is benzoyl chloride. Hydrogen atom will be substituted by benzoyl group. So CH3NH, one of the hydrogen atom, being replaced by COC6H5, that is benzoyl group. How will this compound be named? N with nitrogen, you can see methyl group is binded. N methyl, and the parent compound is benzamide. Now, reaction of amines with nitrous acid. Here we will discuss the reaction of primary aliphatic as well as aromatic amines with nitrous acid. First of all, nitrous acid, that is HNO2, is prepared in situ, that is inside the reaction mixture. How it is prepared? It is prepared by treatment of sodium nitrite, that is NaNO2, with any mineral acid. Here the mineral acid taken is HCl, but in place of HCl it can be any mineral acid. So when aliphatic amines, here in the equation we have used RNH2, when aliphatic amines react with nitrous acid, in the equation in place of nitrous acid it might be written NaNO2 plus HCl, because HNO2, that is nitrous acid, is prepared in situ. So on this reaction, look at these compounds which are getting formed. Rn2 with a plus charge and a negative charge. These are important class of compounds known as diazonium salts. So diazonium salts are formed. What are diazonium salts? Diazonium salts are the salts having N2 with a positive charge on nitrogen, that is diazonium ion. This is diazonium ion. And if the nitrogen of diazonium ion is binded with alkyl group, it is aliphatic diazonium salts. But aliphatic diazonium salts are quite unstable. Therefore, these diazonium salts, since they are aliphatic and unstable, hydrolyze itself, and finally alcohol are getting formed, and the most important is the complete nitrogen present in these diazonium salt is liberated in the form of nitrogen gas. That is the reason this reaction is used in the estimation of amino acids and proteins by estimating the nitrogen in them. Amino acids and proteins, both the substances have nitrogen in them, and by this method the nitrogen present in them is estimated, and therefore reaction is used for the estimation of amino acids and protein. Same type of reaction with nitrous acid takes place with aromatic primary amines. Let's see. This is aromatic primary amine. Common name, many times we have used this compound, that is aniline. When aniline is treated with nitrous acid, first of all, this reaction takes place at absolutely low temperature of 0 to 5 degrees Celsius. That means in Kelvin 273 to 278 Kelvin. And here also diazonium salts are formed. But here the diazonium salts are aromatic, as the nitrogen atom is binded with aryl group. And aromatic diazonium salts are comparatively stable than aliphatic diazonium salts. These are the side products. So this is the reaction of primary aliphatic and aromatic amines with nitrous acid. Coming to next important reaction of amines, that is carbylamine test. Why are we giving this name as the test? Because this reaction is used as a test. Let's see what is this reaction and why it can be used as a test. First of all, carbylamine reaction is given only by primary amines, both aliphatic as well as aromatic, but not by secondary and tertiary amines. What is this test? When primary amines, whether aliphatic, whether aromatic, are treated with chloroform, that is CHCl3, and ethanolic solution of KOH, then this alkyl group or aryl group, whatever is there in the amine, that alkyl or aryl group is binded. Now you can see in the product with a new functional group NC. It is isocyanide. That means isocyanides are formed. Another name for isocyanide is carbylamine also. And these isocyanides have a very foul smell. That is why if in the reaction isocyanides are found, they are recognized by their foul smell. And these are the side products. And because this reaction is only shown by primary amines, not by secondary and tertiary, and also the isocyanide formed can be recognized by its smell, this is the reason this reaction is used as a test to distinguish primary amines from that of secondary or tertiary amines. That is why it is known as carbylamine test. It is also known as isocyanide test. Means if you want to know that whether the amine given to you or any sample is a primary amine or not, we have to perform carbylamine test. If we are getting a foul smell substance, that means it is primary. If not, it may be secondary or tertiary. This is carbylamine test. Coming to next reaction of amines, that is reaction of amines with Hinsberg's reagent. What is Hinsberg's reagent? Hinsberg's reagent is aryl sulfonyl chloride. Aryl sulfonyl chloride is Hinsberg's reagent. Hinsberg's reagent. As I told you, Hinsberg's reagent is aryl sulfonyl chloride. In the form of formula, we can write it as C6H5, the aryl group. Here we are taking is phenyl, and sulfonyl chloride is SO2Cl. This is Hinsberg's reagent. Here with Hinsberg's reagent, primary, secondary, tertiary, all the three types of amines react in a different manner. And the reaction given by all the three types of amines again can be used as a test. Here the test can be used to distinguish between all the three types of amines, that is primary, secondary and tertiary. Let's look at the reaction, how this reaction takes place. First of all, we will look reaction of primary amine with Hinsberg's reagent. This primary amine, for example, here we are taking ethylamine, IUPAC name ethenamine. When primary amines reacts with Hinsberg's reagent, that is C6H5 SO2, I am drawing the structure of Hinsberg reagent Cl. Primary amine is reacting with Hinsberg's reagent. One hydrogen atom attached with nitrogen and Cl from Hinsberg's reagent is removed in the form of HCl, that is, it will be the side product, and the remaining portions of both the compounds will bind together. And let's look what are the compounds formed. C2H5, the same alkyl group which is present in this primary amine. This NH2 will now be NH, and this nitrogen will now bind with this SO2, and phenyl group is also there. So this is the compound. Now what are these compounds? In these compounds we can consider that SO2NH2 is the functional group which is known as sulfonamide. Like CONH2 is amide, SO2NH2 is sulfonamide. Name of this parent compound, considering benzene in the parent compound, is benzene sulfonamide. But in this benzene sulfonamide, we can see here with nitrogen, one ethyl group is binded. So how will we name this compound? N-ethyl, or whatever alkyl group is attached here with nitrogen, name of that alkyl group. Here it is ethyl. So N-ethyl benzene sulfonamide. So the product formed is sulfonamide. N-ethyl benzene sulfonamide. That's okay. Now we can see here in this N-ethyl or any alkyl benzene sulfonamide, this SO2 group is here. SO2 group, like a carbonyl group, is a strong electron withdrawing group. That means it have a tendency to attract the electron pair of sigma bond towards itself. Strong electron withdrawing group is this SO2 group, and due to this electron withdrawing nature, this nitrogen, I am showing this hydrogen attached with nitrogen separately right now. Due to strong electron withdrawing nature of this sulfonyl group, nitrogen tends to attract the electron pair of NH bond towards itself to compensate the loss. And this hydrogen in that case will be released in the form of H plus ion, because both the electrons of this NH bond are taken by nitrogen, and that means in this benzene sulfonamide, N-alkyl benzene sulfonamide, which is the product of reaction between Hinsberg's reagent and primary amine. Due to this hydrogen, this is acidic in nature, and because it is acidic in nature, it is soluble in alkalis. So this is how primary amines reacts with Hinsberg's reagent. Now how secondary amines reacts? The same equation, I will make some changes. Hinsberg's reagent will be same, that is aryl sulfonyl chloride. In place of primary amine, here I am changing it to secondary amine. How will I change it? Replacing one more hydrogen by one more alkyl group, that is C2H5 twice NH. This will be secondary amine. It will react with this Hinsberg's reagent exactly in the same way. H of this amine, Cl of this Hinsberg reagent will be eliminated in the form of HCl. Remaining portions will bind, and look here, what will be the product here in case of secondary amine? Here it will be C2H5 twice. How will we name this compound? Now because with nitrogen, two ethyl groups are binded, we will name it as N-diethyl benzene sulfonamide. And reaction is taking place in the same way as it was taking place with primary amine. But here you can see in the sulfonamide, the product which is formed, here now there is no hydrogen attached with nitrogen. That is why secondary amines reacts with Hinsberg's reagent to form a product which is not acidic in nature, therefore insoluble in alkali. Primary amine was reacting with Hinsberg reagent to form a product which was acidic in nature and therefore soluble in alkali. This is how secondary amines are taking, reaction is taking place. Now what about tertiary amines? Tertiary amine, one more hydrogen will be replaced by one more alkyl group, and the tertiary alkyl here we can take is C2H5 thrice N. Now we can see here that in tertiary amines itself there is no hydrogen attached with nitrogen. In tertiary amines, since there is no hydrogen atom attached with nitrogen, and therefore when it will react with Hinsberg's reagent, HCl molecule cannot be eliminated because as there is no hydrogen here. So tertiary amines do not react with Hinsberg's reagent at all. So no reaction will take place. This means primary, secondary and tertiary amines are showing different types of reactions with Hinsberg's reagent. That is why Hinsberg reagent or Hinsberg's test can be used to distinguish all the three types of amines, that is primary, secondary or tertiary. These were main chemical reactions of aliphatic amines. Now we have to talk about some specific reactions of aromatic amines. And the primary aromatic amine, the simplest aromatic amine, aniline, we will discuss its some specific reactions in our next class.